It's very simple. If you understand the basics of what I'm saying, we can use light frequencies to replace drugs. In fact, Tina Crew, the person that we were talking about at lunch, she wrote a very interesting paper. If you want to look her up, Tiina Carew, Kuru. She wrote a paper. The title of it is Red Light, a Drug Therapy. And after you read the whole paper, the last line is Tina Crew goes, I come to the conclusion that it is. So that means that every frequency within PBM, which is 600 to 1100 nanometer light, actually does something that Big Pharma has a pill for.
Is red light always the solution?
Red light is, I will tell you, it's the base. The one thing you need to know about red light is from the time the sun up to the time sun's down, red light is present. Now, here's the interesting thing. IRB, IRC, which is also in the solar spectrum, because solar spectrum goes to 3100. Like if you go to the desert, down where you're at, you can feel the rocks are still hot when it's 50 degrees out. So infrared light's there. So if you have the detector, but that's the basis of the reason why the Scandinavians have shitty light, like geothermal pools, because you're getting that effect. The reason why is because it changes the water chemistry in you. So before
if you go in a hot tub, will it do it, or it has to be geothermal?
No, but it'll work. But I will tell you, there's other things you have to do to really power up. Like say, I think it was at the event that you and I were at with Neil Strauss. There was a guy there with the soaking tubs, like the sensory deprivation tubs. Mm-hmm. And I told him if you wanted to increase the effectiveness of this, he should add music, different types of music that affects the coherence in water, and red light. I said, if you do that, dude, that's a winner chicken dinner, because basically you just created a pod that a baby is in the amniotic sac. That's effectively what you're doing, because the mother's heartbeat is doing the same thing to that amniotic sac. We know that. The crazy part of the story, going back to neurosurgery, when you were talking about, that's the paper that I posted, that you can slice the brain up and you can still measure the waves after you slice the brain up. How did I learn about this a long time ago? When I actually did rotations in functional neurosurgery, that's what Eddie Chang does. We used to do subpeel restrictions on the cortex. That's basically like taking a knife and cutting a gyri to stop a seizure focus, from generalizing other places. The funny thing is it didn't work in everybody. And the reason it didn't work is for what you just said.
Haptic communication.
Right. And here's the other thing that we just found out you're going to like, is that every time an action potential happens in a neuron, do you know what neurons also release? Water, which goes to what he was just talking about. So I'm going to tell you about an experiment that's going to blow your mind. Again, published in Nature magazine. So we're not talking little one. Guy that won the Nobel Prize for HIV, Luc Montagnier, just died. He found that DNA acts as a topologic insulator. That is a form of a wide-base semiconductor. He was able to take that DNA, put it in water, leave the water there, took all the DNA out, took the water, transmitted the signal, the electromagnetic signal in the water over the internet to another city in Europe. Went into the water, and they were able to recapitulate DNA that was exactly the same. So guess what? You just said, is telepathy real? What if I told you the first paper is already published and it's out there, but you know why it doesn't get any traction? Because Andrew hit it on the head. When something offends biologists so much because it's not in their field, they ignore it. Or they make fun of it.
Tell me what the paper is.
I forget the name of it, but I can get it for you. It's been in so many of my blogs.
Yeah.
But he brought other people in. And the sad part is he just died, literally in the last year. But he, huge believer, anti-Fauci. I mean, because Fauci was good friends with Gallo. Remember, Gallo tried to steal the Nobel Prize, but the Nobel Committee realized Montagnier was the ticket.
Well, one of the things that I've heard some of my colleagues say that I really support is that, when you're on a hiring committee for, say, neurobiology, and I actually think Stanford has done this well, to try and bring people from disparate fields into a field. If you're hiring a neurobiologist or you're hiring somebody in, immunology, a lot of times you pull from people that came through laboratories that you know very well because they're already in your field. But to really shake up a field and to really make ground, you want computer scientists, you want engineers, you want physicists, you want people that have enough understanding of the problem at hand, but bring a totally new perspective. And certain places have done more of that than others, but it is still very siloed.
It is.
And part of it is that it's hard to read the papers. Like if I read you were talking about your tweets earlier, right? Mm-hmm. So, and today I'm learning a ton, and and you said it yourself, that oftentimes people just don't have the skill set to be able to understand like what a free electron is, to be, let alone,
because of the silo that you came up in.
Yeah,
you don't have the basics.
And some of it's complicated. You got to know quantum mechanics to understand some of this.
I want to make sure that people understand the synonyms we're using, because you're good with words. I understand what he's saying, but I want to make sure the audience is getting this. Silo is a synonym for centralized medicine. In other words, this is what we believe to be true. If you ask a decentralized clinician, which I consider myself, I know that the truth is an approximation of the best data we have today. Therefore, it's subject to change.
Absolutely.
That's exactly the way I look at science. This is exactly the way I came to understand the leptin melanocortin pathway and functionally how we really work as a semiconductive living organism that's a dissipative structure. The only time we're at equilibrium, because you hear that all the time in biochemistry, is when we have rigor mortis. That's the truth. Life is meant to live in the tail. So when you ask me, where did I come up with the black swan idea? That's where it comes from. It's a tail event. Mitochondriac, because I want you to focus in on mitochondrial DNA, not RNA and DNA, because that's not the story. The story in RNA and DNA is so simple to understand. It's 20 proteins. It acts as a topologic insulator. What does that mean in English? The outside can conduct an electric current, but it doesn't affect the inside the way it works. In other words, atomically inside, it's silent. Why? Because atomic organization at a molecular level is important. Why? All of biology is based on storing light energy at the electronic level. That means in bonds, in protons, in electrons. And it's our job as clinicians and biologists to understand that. We need to understand that science to help our patients. And when we're not, like when we have the epidemic of myopia, we have infertility, we have depression, we have schizophrenia, it's all discoverable when we understand what we're talking about. Why? Because proton tunneling changes how neurotransmitters work. When you put someone in a cold environment, do you know that it doesn't matter if their testosterone goes down? Why? Because the electronic nature of the wide-base semiconductor means it can still work at a testosterone level of 250 because the sensitivity to the receptor goes up. We don't know that in centralized medicine, but I know it. Why? Because I do it in patients all the time. You had